Coming up, Rosetta lands on a comet.
SpaceX releases an update for their anomaly.
And Jared has an interview with the Martian Garden. All that and more coming up right now, today on Tomorrow.
Hello and welcome to Tomorrow, episode 9.30 for September 24th, 2016. And we're very glad to have you here today. But before we get the show officially started, we want to give a big shout out to all of our Tomorrow Premier members through our Patreon. Look at these amazing people. These folks are awesome because on our Patreon at patreon.com/TMRO, they give us $10 or more per episode. And by doing that, these folks get access to everything. That's right. They get access to our After Dark as soon as it's posted, our show as soon as it's posted, our Slack channel where you can actually see all of us sort of chatting around and having a really fun time with each other, and also talking about the show and seeing things that the public doesn't get to see just yet about our show, like our new set and some of the upcoming things. So if you would like to help crowdfund the shows of tomorrow, head on over to patreon.com/TMRO. And of course, I'm your host for today, Jared Head, because Ben is, well, he's off somewhere on a double secret mission. And we probably don't have to tell you what he's working on, because you could probably figure it out on your own. But to my left over here, your right, in the middle, the man on the screen, trapped in the box, and from the hotlands of Arizona, Space Mike in here. How you doing today, Space Mike? Pretty good?
I'm doing pretty good, pretty good. How you doing today, Jared?
Doing pretty good as well. And then, of course, off to the left, your right of Space Mike, is the beautiful, the talented, the not my wife, the other half that is still here, Carrie-Ann Higginbotham. Carrie-Ann, how's it going today?
Yeah, really good.
Really good?
Yeah.
All right. Well, why talk about ourselves when we're here to talk about space for our show? So, Space Mike, go ahead and take us away.
Well, normally we start the show with a space launch, but unfortunately, there was supposed to be a launch that was supposed to happen yesterday, but a slight error has caused that launch to be postponed. What I'm talking about is the Soyuz vehicle that is going to be sending up the next 3 crew members to the International Space Station. And what happened was, when they were processing the vehicle, after the vehicle was already assembled and they'd loaded it with lots of the toxic propellants and pressurized gases and encapsulating it within its payload fairing, they discovered a short circuit. They discovered a circuit that was bent, and this was inside of the descent module. And you can see here the processing of the Soyuz vehicle. This is the Soyuz MS-02 vehicle, and with it, it was behind the seats inside of the descent module where the astronauts sit, where this bent cable was. And with this, I don't know what the particular cable is for, but you don't want to short circuit at all on any spacecraft for risk of a spark or potential explosions. But since the vehicle is already assembled, the Russian engineers now have to try to repair the vehicle, which is normally against safety standards. So they are weighing their options. If they proceed with the risky repair and are successful in it, they could launch the vehicle sometime in October if everything goes well. Otherwise, they're going to have to unload all of those propellants before trying to repair the vehicle, which could take months. The other option is to use the next Soyuz vehicle that's in the production line, which is meant for Soyuz MS-03 mission. And this is the crew that you're seeing on screen for the Soyuz MS-02. It will be the American astronaut Shane Kimbrough and Russian cosmonauts Sergei Ryzhikov and Andrei Borisenko. So whenever that mission does go off, this will be the crew, whether it be in their vehicle that's having the problems now or the next Soyuz vehicle in the production line. And either way, both vehicles will eventually be used, but it's just whether or not they're going to proceed with this very risky type of repair, because if they do have anything that goes wrong and they get lots of sparks or anything like that, things could go very, very, very wrong. So it's kind of a sticky situation, but I'm sure that the Russian engineers will make the correct decision.
Yeah, hoping for that other option, which is just to go ahead and pull up the next Soyuz and get that ready to go. Because, working on a fully fueled spacecraft, that doesn't sound like a particularly pleasant way of going about it.
Well, and better safe than sorry all the way around, so.
Yeah, as our chat room was saying. So, yeah, really good stuff. So, I want to tell you guys about something that's happening next week. So this coming Friday, which is going to be a very cool thing, the European Space Agency's Rosetta mission is going to be wrapping up over nearly, 12 years of mission time with this. So Rosetta, which is the spacecraft that is in orbit around this comet here, 67P, or you could also call it Churyumov-Gerasimenko, but we'll call it 67P, a little bit easier to repeat that. It's heading to its final destination, which is going to be the surface of 67P. Now, like I said, Rosetta was launched in 2004. It arrived in August 2014. It dropped the lander Philae to the surface in November 2014. It orbited alongside 67P as it went through perihelion in 2015, and Rosetta has orbited many times around this comet at a multitude of distances to gather as much data as possible. Now, this morning, Rosetta entered into its final orbit, and what it's going to do is it's going to end up going until it reaches a point that on September 29th, it will begin what is called a collision maneuver, which most of the time when you're working with a spacecraft, you don't want a collision maneuver. But in this case, that's what they are doing. Now, it will spend the better part of 24 hours descending to the surface, and that impact will occur sometime on September 30th, hopefully at a speed of about 1 meter per second. Now, the European Space Agency expects to basically lose contact upon the, the lithobraking event on the surface of the comet here. So Rosetta will be landing in an area known as Ma'at-2, and I probably butchered that, but the name, it's named after the Egyptian goddess for the concept of truth, justice, mortality, and harmony. So there you go. That area you see in the middle, that is where they're going to attempt to land Rosetta. Rosetta, not designed to land on a comet, so this is going to be very, very interesting to see, and we'll have to see if any problems arise, or if nothing goes wrong and we end up getting more data from the surface of the comet. That would be the best outcome from this. So pretty cool stuff. Now, Space Mike, you have an update for us in a story that we said we would only talk about if there were actual facts to talk about it. So, Space Mike, take us away.
That's right. Speaking of problems and data, SpaceX yesterday released an update regarding the whole accident that occurred with their Falcon 9 and the Amos 6 spacecraft at Space Launch Complex 40. Now, the accident investigation team has collected most of the debris from this accident. And with this, what they've been able to do is they've been photographing and cataloging just about everything they can, and it's assembled in one of their hangars nearby. And as there's doing this investigation, what it looks like is that one of the helium tanks inside of the upper stage is what caused the initial explosion. They still don't know for sure what the exact cause of the explosion was, but it's looking like that's might have been where the problem started. And with this, to quote from their press release, it says that at this stage of the investigation, preliminary review of the data and debris suggests that a large breach in the cryogenic helium system of the second stage liquid oxygen tank took place. All plausible causes are being tracked in an extensive fault tree and carefully investigated. Though the fault tree and data review, through the fault tree and data review process, we have exonerated any connection with last year's CRS-7 mishap. So this is not the same type of problem where a strut holding one of those helium tanks wasn't up to strength and caused it to shoot up. So we're not exactly sure what the exact problem is, but I think it's very interesting that these helium tanks are another source of problem. But in regards to the pad itself, we actually have some footage from Lisa Stojanovsky that she took recently of the pad. And SpaceX said that their Falcon support building, which is adjacent to the pad itself, was unaffected. And that thankfully, very thankfully, their liquid oxygen and their RP1 or kerosene fuel farms, which is where they store all the fuel that has all the different plumbing that can fuel up the rocket were not damaged. So that's very good news. They also said that the pad's control systems are in relatively good condition. So despite some of the damage that we've seen, a lot of what we've been seeing from the pad there might not be as bad of damage as some people have been speculating. And in regards to places nearby, I mean, Space Launch Complex 41 that United Launch Alliance operates from wasn't damaged at all. Space Launch Complex 39A that SpaceX is going to be launching their Falcon Heavy and Falcon 9 rockets from, hopefully as soon as November, or at least have the pad ready as soon as November, was not damaged at all either. It seems like there wasn't any debris that went outside of the immediate area of Space Launch Complex 40. So that's good news for everyone else and good news for SpaceX, so that if everything is able to proceed along in a good way, that they will be able to continue to operating from LC-39A. And we're just going to have to wait for more information to find out what the definite cause of this accident was and how long, if we are given estimates of when SpaceX could start launching from Space Launch Complex 40 once again. So even so, though, it's great to have an update as to what's been going on, and they have definitely not been slacking. So.
Yeah, well, good to hear that they're moving ahead with that and that they're attempting to figure out what the problem was. So coming over to the West Coast here with some of our launch pads, we've had some issues out at Vandenberg Air Force Base of late. Some very weird issues.
It's like total depressisode.
Yeah, well, we're trying to like make it super interesting, happy, good times, but this has been like a bad month.
Yeah.
September is like become September 2016, the cursed month of spaceflight, is basically what it's become. And some of you may have known about this because we were actually going to get ready to cover the launch of Worldview 4 actually live at Vandenberg Air Force Base. But we ended up not being able to because a wildfire broke out on the base. Now, it was named the Canyon Fire, and it ended up threatening assets at Vandenberg Air Force Base, historical sites of the indigenous people of California who used to live there, and the outskirts of the city right next to Vandenberg, which is Lompoc, California. Now, the fire began the evening of September 17th, and it quickly spread and forced the scrub of September 18th's launch attempt of Worldview 4, which now has no date set for launch. And you can see this unbelievable image right here. This is Space Launch Complex 6, or what we also call Slick 6, which is where the Delta IV vehicles are launched from here on the West Coast into polar orbits. And you can see the fire came right up to that launch complex there. So, it threatened both the SpaceX pad and the Atlas V pad in the southern portion of the base. Now, as of this morning, the Canyon Fire is fully contained, having burned 12,500 acres. Two other fires also occurred within the week of the Canyon Fire, but were quickly contained. And the source of the Canyon Fire is still under investigation, so they actually are unsure of how it occurred. So they're still going to be taking a look at that. Now, speaking of United Launch Alliance, because we just talked about a ULA launch that scrubbed, Space Mike, you've got some awesome news from United Launch Alliance.
Yeah. Hopefully this will cheer you up a little bit, Carrie Ann. So previously here on Tomorrow, I reported that ULA has been offering free rides for CubeSats that universities have built on their Atlas V vehicle. And they recently have announced 4 winners that will be in this year's round of their program, which they have recently named CubeCorp. And I really like this. I don't know exactly what type of CubeSats the winners have built, but for this, the winners are, in first place, University of Texas at El Paso. Second place is University of Louisiana at Lafayette. And then the other 2 winners are Purdue University and the University of Michigan. Now, even though we don't know what type of CubeSats they're going to be launching with United Launch Alliance, the United Launch Alliance method of deployment is able to accommodate up to a 3-unit CubeSat, which is your basic CubeSat. You have 3 of them stacked together. And we have an animation here of their method of deployment. They have a really really interesting system called Ultrasat, which is attached to the aft, or rather the bottom of their Centaur upper stage. And they've already done several missions like this. In fact, one of their most famous CubeSats that they've deployed was the Planetary Society's light sail. And here is some real footage of them preparing this Ultrasat deployer that is able to hold, I believe it's up to 9 3-unit CubeSats, or more than that if it's less. And there's some real footage of some of those CubeSats being deployed in space. Very quick, but still very awesome. So I'm very excited about this. And one of my favorite quotes about this program, in the sense that they're giving these rides away for free to these universities, is Tori Bruno once said that you could not pay us to get rid of this CubeSat deploying system. And we are going to continue to offer these rides for free for as long as we're flying the Atlas V and hopefully the Vulcan rocket as well. So I'm very happy about that sort of mentality, and that these universities who have tons, some of them have dozens of CubeSats just sitting on the shelf that students have built for different engineering and science projects that might not ever get launched. So this is a really great opportunity for that. And they will be doing more opportunities in the future as well. So hopefully I'll report on that for anyone who's interested.
Yeah, very nice of ULA to do that to the community. It really helps out, especially students who want to be engineers, to actually have that. I worked on actual hardware that went into space. That's like, that's pretty good to have on your resume coming out of college. I'm just saying. So
yeah.
That's some pretty good stuff. So I want to talk about some really exciting news from the outer solar system about dwarf planet Pluto. And guess what? I could say dwarf planet Pluto because somebody isn't here to correct me.
Yeah, neither of us are going to argue with you.
Okay, Dudda's going to argue with me about it, but that's okay.
No one can hear.
Dudda's a director, so he's just a producer. What does he know? Anyways, we want to talk about dwarf planet Pluto because there's a surprise that has come out of the data that, by the way, is still coming back from New Horizons. They've still got about 3 more months of data to continue to downlink from New Horizons, from the flyby, okay? So 48 hours worth of data gathering, they're still downlinking it from that far out. So just because it's so slow, it's slower than some internet connections in the United States. But there's a really cool thing that happened here. Recent studies using computer models have narrowed down the geology of Sputnik Planum. And Sputnik Planum is that big heart-shaped area there. And they have found that it can only occur under conditions primarily ruled by a subsurface ocean. Now, Sputnik Planum is about 900 kilometers across, and it was most likely formed in a major impact event. And the interaction from Pluto and Charon, Pluto's moon, because they are tidally locked and their rotation is also locked with each other, this allows the impact basin area to be refilled. So instead of all of that material getting pushed out, it actually is able to come back in after the impact because of the way that the gravitational interaction works between Pluto and Charon. Now this means that you can keep more heat from the impact in that area, and you can keep that heat insulated as well, so that way it stays there for very long periods of time. Now models show that terrain that we called chaos terrain is only able to sustain itself with the currently seen convective areas. So those big sort of weird polygon shapes that you see right there, that's actual nitrogen ice that's being convected upwards, like boiling water, but in very slow speeds and with nitrogen at like minus 230 degrees Celsius. So some super cold action happening there. Now, this happens because there's most likely a subsurface ocean there with 30% salinity, and that subsurface ocean in that area is probably about 100 kilometers deep. So more surprises from Pluto that we keep finding out every week, and this has like quickly become the mission for the ages with New Horizons and everything that we have learned about Pluto. And even though I say that Pluto's a dwarf planet and I stand by that very strongly, it's still basically my favorite place in the solar system. And I totally want to go there. We should definitely go back there. What do you guys think? Should we go back?
Yeah.
I think we should almost change the name. We should call it like New Sputnik Lake or something like that, since we already have a Sputnik Lake here.
Maybe we can name it after actual lakes, you know,
Yeah.
like Vladivostok 2 or something, you know. That would work out pretty well. All right, so we're going to go ahead and head to break. And when we come back, we've got Mark Cusimano, who is the Martian gardener. Yes, that's right, not Mark Watney. We've got somebody else who is the Martian gardener, and we're going to be talking with him of just about, you know, what exactly is the Martian gardener? And this is going to be a very, very cool interview. So stay tuned, and we'll be back right after this break.
Look into her face, determination in her eyes. She won't give up or quit or fall for little fashion lies. Films on some expectation. This girl's a fascination. Nothing in her way will keep her from her destination. 'Cause she's fire walking. She's fire walking. When it's hot, she keeps on moving. Her heat keeps on improving. Yeah, she's fire walking. She's fire walking to be free.
And welcome back from break. Now, before we get into our interview with the real Martian gardener, we first would like to once again thank our Tomorrow Premier members for their support on our Patreon at patreon.com/TMRO. But wait, there's more. We also have our Tomorrow producers. These folks, they give us anywhere from $5 to $9.99 per episode, and they get access to our show immediately. They get early access to After Dark. I believe they also get free shipping from our swag store, right?
Ooh.
So you get a lot of good stuff, even if you are a Tomorrow producer as well. And of course, we love everybody who helps us out. And if you would like to help crowdfund the shows of tomorrow, you can head on over to patreon.com/TMRO. Now, we have got our guest who I've been eagerly awaiting talking about this because this is just such a cool project. We have Mark Cusimano. And Mark, we're very glad to have you on the show today.
Well, thank you, Jared. I'm really excited to be here. Been a fan of the show for a long time, and it's really exciting to actually be a guest on tomorrow.
All right. So you run a website called The Martian Gardener, which is a project that you have been doing on your own. So just go ahead and tell us, what is The Martian Gardener?
So the Martian Garden is a line of desktop garden kits and other products that include a product called Mars Regolith Simulant. Now, what Mars Regolith Simulant is, it's actually a blend of Earth materials that gets about as close as we can to the chemical and grain size of the soil, also known as regolith, that we find on the surface of Mars.
Now, you guys actually started out as a Kickstarter project, if we're remembering correctly. So could you tell us a little bit about how you ended up sort of getting this project going? What was sort of the inspiration to make this?
So for the inspiration for us, we really have been trying to find some way to engage with particularly the amateur science community, the citizen science community, makers, in a way that can help people get involved in space in ways other than kind of the traditional hobbies, like, you know, amateur astronomy and high-power rocketry and things like that. We wanted to try to add something new to that kind of a lineup. And with the Martian Garden, we're hoping that we can provide citizen scientists and students with not only an interesting way to get engaged in space exploration and astronomy, but maybe provide amateurs with the means that they need to develop the technologies and the techniques that we're going to need on the journey to Mars.
Now, Mars regolith is not something that we end up, grabbing from Mars and bringing it back, because we haven't done a sample return with any mission to Mars yet. We kind of talked before the show that there's a real cool story about how you guys were able to make Martian regolith. So how do you guys actually make the regolith that sort of simulated Mars regolith?
So that's a really awesome story. I think that the story for Mars Regolith Simulant really starts at the beginning of the solar system. When the sun first formed, and we still had the protoplanetary disk, and the planets were coalescing. The inner planets, the terrestrial planets, Mercury, Venus, Earth, and Mars, all formed in a very similar way because they were pretty close to each other. And in the protoplanetary disk, the heavier elements, like, for example, iron, silicates, oxygen, these were pulled in close to the sun due to their relative weight compared to, say, hydrogen and helium. This is why we see terrestrial planets instead of gas giant planets when we move closer to the sun. And that was an important thing because that means that Mars and Earth formed relatively in the same way and from the same basic pool of materials. Now on Mars, it seems like Mars was smaller. So when it was a molten ball just kind of coalescing in the early solar system, it had a little bit less iron than Earth did and a little bit less iron than Venus and Mercury and so forth. But since it was smaller and it didn't heat up quite to the same extent that Earth did, this iron was kind of locked into the crust of Mars because it never liquefied all the way. It never precipitated down to the core the way it did on Earth. As Mars cooled, this resulted in a much higher iron concentration on the surface than what we find on Earth. And of course, this is what results in Mars' red color today. Now, after Mars had formed, of course, the early Martian environment was much warmer and wetter than modern Mars as we observe today. And water was one of the big erosion factors when it still was wet. You can see that in Valles Marineris, you can see that in the river deltas, you can see that in the many signs of water erosion that are across the planet. But one big difference between Earth and Mars is that Mars didn't have a way to recycle its crust the way that Earth did with plate tectonics. So we find a very ancient surface on Mars that's been eroded for a very long time, covering the planet with this kind of iron-rich, igneous dust. And by using what we know about the geology of Mars and the geology of Earth, we can compare the kind of chemistry that missions have found on the surface of Mars with things that we know about Earth and find really close analogs to it.
All right, so we've got some really great questions coming from our chat room, and some of them are very technical. I guess is the best way to put them. So there's a very big group of people that are wanting to know what the mineral content is, because we know we find things like perchlorates on the surface of Mars, and a couple people specifically asked if there are things like perchlorates in the simulated regolith that you guys are selling.
So we have made the decision not to do any kind of perchlorate additives. And of course, that's a recent discovery from the surface of Mars that there are perchlorates in the soil. And that has some big implications for growing plants on Mars because the perchlorates are taken up by the plants and they accumulate in the vegetative growth. It's something that we have to find a solution to if we're actually going to grow crops on Mars. However, perchlorates have some pretty significant health hazards. They've been implicated in thyroid problems, and we're not equipped to either handle or ship those kind of hazardous substances. So what we've elected to do is for advanced amateurs who want to add, perchlorates, additional iron oxides, and things like that to the soil, that's where we'd like to see that happening. Now, to address the questions about the actual composition of it, the biggest difference between Mars regolith simulant and the measured properties of the surface of Mars by the various surface missions there, the biggest difference is going to be in the ratio of aluminum oxides to iron oxides. In particular, materials on Earth are going to have much higher concentrations or relative concentrations of aluminum oxides, while materials from Mars are going to have a much higher concentration of iron oxides, and of course, red. That's where we're seeing that. Now, there are some other small differences. For example, I want to say that Mars has a higher concentration of sulfates as well. These kind of trace elements are rarely more than a 5 to 10% difference. By far, the biggest difference is going to be in the relative concentrations of aluminum and iron oxides.
So just a question from our chat room, kind of putting a couple questions together and then paraphrasing it. What's the difference between your simulated regolith and some of the stuff that NASA, like the Jet Propulsion Laboratory, may work with their simulated regolith? Like when they're working on their rovers, like when they were trying to figure out how to free spirit and they were using their versions of simulated Martian regolith. What's the difference between yours and what NASA may be using?
Sure, that's actually kind of chapter 2 of our Mars regolith story. When we set out to do this, we really relied on research from NASA and the JPL to guide us in the right direction. And in particular, these are guys who have landed on Mars. They know more about its surface composition than we do. So we started to follow the tracks that NASA had put out with their publicly published articles, and The first place we arrived was at a product called JSC Mars 1. JSC Mars 1 was developed at Johnson Space Center in the 90s based on lessons learned both from the Viking landers and from the Pathfinder mission with its Sojourner rover. Prior to that, there wasn't much data about the actual composition of the surface of Mars. But in the development and the deployment of the Mars exploration rovers with Spirit and Opportunity, they developed something called JSC Mars 1. And this is a material that comes from a cinder cone in Hawaii called Pu'u Nen, and it's in the saddle right between Mauna Kea and Mauna Loa. This is a material that's formed from a basaltic magma or basaltic lava that cools rapidly in the presence of water. It creates almost like a volcanic glass and obsidian ash. And in the 90s, NASA and the Jet Propulsion Laboratory obtained a quantity of this JSC-1. But while they were doing development work for the Mars Phoenix lander, which of course is the one that landed in the polar regions with the scoop to look for permafrost below the Martian soil, they found that JSC-1 had some rather unfortunate characteristics with regards to how it absorbed water. In particular, they were studying how water ice sublimates directly into water vapor in ambient Mars conditions, and they found that JSC-1 had a tendency to form kind of a clay. So they decided to develop something new called Mojave Mars simulant. And Mojave Mars simulant is very different in one important aspect, which is the shape of the grains. Since JSC-1 was eroded naturally, it had a very round grain shape. But MMS, Mojave Mars simulant, has been mechanically crushed. And this gives a much more sharp angular shape and makes it a lot more difficult for the material to absorb water and become a clay. So they used this in the development of, I believe, Phoenix, Curiosity, and the upcoming 2020 rover, I believe. And, well, they obtained it from a company called Carlton Global Resources. Unfortunately, they went out of business, but we were able to identify the company that currently operates the site where JPL obtained their Mojave Mars simulant. And we can say at this point, with X marks the spot confidence, that we are obtaining our supply from the exact same quarry and the same rock deposits that JPL used to obtain MMS.
Very, very cool. So just a little introduction. You sent us a kit, one of your Gardener kits. And could you tell us what's in the actual kit itself?
Sure. So I've actually got one here handy. The basic kit is a small dome, and open it up, and you find inside some Mars simulant material. There we go.
Ooh,
and
nice.
a couple of little planties. Basically, the primary components of the kit are the garden dome itself, a small sheet of root blocking material, because it's very fine-grained stuff, and you don't want it falling through the drain holes.
Yes.
So you'll put a little piece of blocker material at the bottom. You fill it up with the included Mars regolith simulant. Water it down a little bit, because this stuff is very dusty. The first time that you use it, it actually floats around like a talcum powder or a baking powder or something. But after that, it acts very much like a really rich volcanic soil. And the propagator dome that's included with it kind of helps to keep the humidity in for the seedlings. Because what we've found is that because it's a volcanic soil, it drains relatively quickly. Water evaporates from it relatively quickly, and it's a good idea to retain it for the seedlings.
So kind of combining some questions together that we have. Obviously, our viewers are very excited about this, and they're all almost universally asking, how well do plants grow? But also from Tarantula, one of our viewers, they also want to know personally what plant has had the most success so far that you've seen in growing in this kit.
So far, the plants seem to be doing really well. In general, the regolith simulant behaves like a soil that's very rich in inorganic nutrients and very poor in organic nutrients. So for many of your viewers, I'm sure have seen The Martian, you do need to add some sort of an organic nutrient supply, whether that's freeze-dried poop or not. And in terms of which plants have been growing the best, so far we've had the best luck with backyard weeds, just weeds from our yard. They're very resilient to all sorts of stresses, and for the amount of manipulation that we've been doing with the soil as we fixed the prototype and stuff, we found that they were very forgiving little plants. In terms of our next round of plants, I think that basil is probably going to be the species that we try next.
Okay. And was there really much of a performance difference between Earth soil and Martian regolith when you were growing the plants?
Not once we had added some organic nutrients. Before that, what we found was there was a lot of yellowing in the leaves. And what was happening there is that I'm sure some people are familiar with the NPK blend in a fertilizer. That's nitrogen, phosphorus, and potassium. And there wasn't a lot of that in the soil at first. And so what we would find is that the lower leaves on the plants would turn yellow. And what was happening was the plants were actually taking nitrogen from their older growth to support newer growth. Once we added a proper NPK blend to the soil, that stopped, and they've been really thriving. Because with the abundance of the inorganic nutrients that the soil offers, just giving it a little bit of organic nutrients really makes it take off.
All right, and you know, like I said, we've got our own kit right here that you sent us, and we're really looking forward to taking this out. And we're probably going to hand it off to my mom, who I was talking earlier as a florist, and we're going to see what she can grow with it, and we'll definitely make sure to give you the results. And let
Please,
you know.
Yeah, I'm looking forward to it.
Yeah, we can let you know what would be some nice, beautiful flowers potentially to grow on there. But also with the kit, what seeds come with the kit? Is there a specific set of seeds that come with it?
Right now, we're leaning towards the Arabidopsis species, also known as the mustard plant. The reason that we're selecting this is because Arabidopsis is a model organism in biology. There's a huge abundance of research that's been conducted with the mustard plant, so that people, if they do decide to share what they learn with the Martian Garden, that they're going to be talking a similar language to professional botanists. And then we're also probably going to include a variety of just kitchen herbs, basil, parsley, oregano, that kind of stuff.
Very, very cool. And of course, if anybody who's watching this wants to actually get their own Martian Garden kit, how should they go about doing that?
So the easiest way is probably to go to our website, which is www.themartiangarden.com. We are currently running our Kickstarter, and the goal for our Kickstarter is set just to achieve the minimum order quantity from our suppliers, and then to go out there and get it. The supplier Rio Tinto Minerals is being really awesome, and they're letting us go out and use this quarry that they acquired from Carleton Global Resources. And the only catch is that we've got to go get the material ourselves. So if we're able to successfully fund our Kickstarter, we're going to have the funds we need to both purchase the material and go out there and get it and process it. And after that, we'll be just offering direct sales on the website.
All right. Well, Mark, thank you so much for coming on the show today and telling us about how people can become their own backyard Watneys at home. And we're so looking forward to seeing what you guys do with this, seeing if you guys maybe expand it sometime in the future. And of course, great. Best of luck to you on the Kickstarter, which I know it seems to be going pretty good so far.
It's going all right. I just want to say, Jared, thanks again for the opportunity to come on the show. This was a real honor to be on tomorrow.
All right. Well, thank you, Mark, once again for coming on the show, and especially for sending us our own kit. We're going to really have a lot of fun working with it. So we're going to go ahead and take a break, and when we come back, comments from last week's show. So stay tuned, and we'll see you right after this break.
We've always looked to the stars. They guide us, give us comfort, help us find our way. We see ourselves out there. When we look up, it inspires us. And we long for something we don't yet know. We yearn to go there. So, we venture forth.
We choose to go to the moon in this decade and do the other thing, not because they are easy, but because they are hard. Because that goal will serve to organize and measure the best of our energies and skills.
Tranquility Base here. The Eagle has landed. It's one small step for man.
The exploration of space will go ahead, whether we join in it or not.
Many think we stopped exploring. But we know our journey didn't end. We've only just begun.
Orion is functioning perfectly at this point.
Come with us and explore tomorrow.
Oh, that break always puts a little tear in my eye when I see it. And of course, welcome back. Before we go into comments from last week's show, we're going to go ahead and thank everybody who throws in a little bit on our Patreon to crowdfund the shows of tomorrow. Of course, our Tomorrow Premiere members, these folks give $10 or more per episode. We also have our Tomorrow producers as well. These folks give anywhere from $5 to $9.99 per episode. But wait, there is, of course, our Tomorrow Plus members, or Patreon Plus members, excuse me. These folks give anywhere from $2.50 to $4.99, and they get early access to our live show, early access to After Dark, and then, of course, we can't forget our Tomorrow patrons. These folks, they can give up to $2.49 per episode, and they get their name in the episode. And we, of course, give our eternal thanks to everyone who helps crowdfund the shows of tomorrow. So if you would like to help crowdfund the shows of tomorrow, head on over to patreon.com/TMRO. And of course, I'm joined once again by Space Mike and Carrie Ann. We're going to go ahead and get right into the comments from last week's show. So, Capcom, what was our last week's show about?
It was hashtag New Origin.
Hashtag New Origin.
Yeah,
All
exactly.
Right. Yes, because we were talking about Blue Origin and their very surprising news, which was, oh, by the way, we've got a really big rocket that we're working on. Just thought we should let you guys know.
Well, wait, and not just one, but like two. Like, we're working on this one, and then, we have bigger plans.
Yeah.
Surprise.
All right, so let's go ahead and just jump into these comments that we've got.
Yeah, so this first one comes off of YouTube from Patty Patron. I'm sure Ben is sad that he's not here to answer this one. Patty says, I wonder what will happen with SLS when all these BFRs start flying. SLS, of course, being the Space Launch System, and BFR being big freaking rockets.
Yes. Well, I think I have a pretty good idea of what's going to happen, and I think I have a pretty good idea of what Ben would say.
Yeah.
Which is that Space Launch System will probably go poof once they all start launching. So
you just erased the paper.
Yeah.
You just erased the lines on the...
literally never happened.
Oh, that was mean, wasn't it? Sorry. I got Dutta to say, aw. Wow.
Oh.
Our Dutta is in my ear saying a whole lot of, he's talking a lot of smack right now. Oh, anyway.
Should we say what Dutta just said?
No, that's fine.
Okay, all right.
But yeah, no. NASA's going to do what NASA's going to do, and that's just, the Senate's going to do what the Senate's going to do, and that's fine.
We'll
the
see
thing
what happens.
Is, here on Tomorrow, as Ben has always been a huge proponent of, and I have to speak on behalf of Ben, so forgive me for a moment while I take off my gentle, nice, sweet, and kind and cute Carrie Ann hat and put on the super, like, this is the way it is Ben hat, is that all ships rise with the tide.
Yes.
Right? So I don't care who's making rockets. I don't care who's building rockets. I don't care where they're going to Mars, they're going to the moon, they're going to the sun, they're going to planet Pluto. It doesn't bother me in any way, shape, or form as long as it continues, the industry continues to grow. And the more competition and cooperation that we can get, the better. Because that means that it's still continuing to grow. And that's all ships rise with the tide. It's all good.
Yes, I like that, cooperation.
Yeah.
I'm going to remember that word from here on out. That's a good way to describe it. All right.
I agree.
So, Capcom, our next comment, please.
Yes, our next comment comes, I apologize, the last comment came off of YouTube. The next comment also comes off of YouTube. This one comes from Nightlurk. It says, it would be brilliantly kick-ass if Blue Origin and SpaceX would start the 21st century's race for Mars and may even pique the Chinese interest to join in.
Ooh, maybe. I mean, Space Mike, China's pretty set on the moon right now, right?
Right. I mean, the first plan, the first phase, and I love the way that they do all of their planning with their 5-year plans. First phase, of course, is their space station, and that'll be the launching point to go to the moon, which they want to do with several partners. And then from there, they might talk about going to Mars, but as of right now, I believe they have their 20 years planned out. And I haven't really seen a whole lot of humans on Mars. They are planning on sending robotic probes, of course, and orbiters to Mars. But that's going to be in the future after they've completed some of their robotic missions to the moon in preparation for their human missions to the moon. So I think that might be a little bit more in the future for China. But who knows? I mean, with the inspiration, if SpaceX and if Blue Origin surprisingly does want to start doing all the Mars stuff instead of doing lunar stuff, then maybe China would be inspired to kind of follow and try to race them to Mars. But I think that this. Who's to say, though, that there isn't already a space race between these companies? Who's to say that there already isn't some sort of gentleman's bet between a couple of these different billionaires doing these space companies,
Sure. The other thing to note, as we've talked before, is that China gets really weird about their launches just kind of in general, right? Like they don't ever put out any footage, blah, blah, blah. Sometimes they launch things, don't tell anybody. Sometimes they don't launch things and they tell people they were successful. Like who knows what's going on over there? So which is to say, like, if A is similar to B, then C kind of logic is what I'm using here. In theory, it could be that China said, oh, we're going to the moon. We're going to the moon. We're doing moon things. We're doing all the moon things.
Moon things.
Once you're on the moon,
what do?
You could also get to Mars still.
Yeah. You could.
It's not like they haven't said they're not going to Mars, but what they have said is that they're going to the moon. See what I'm saying?
Yeah.
So they may or may not be out of that particular race, if you will. Just something to keep in mind.
Yeah, that's true.
How's that?
That's true. That's a good one. You're on it today. You're bringing it.
I've got the Ben vibe. So
yeah, you do. And I'm liking it. It's working out really, really well.
This is why he doesn't let me talk normally. The next.
Oh my gosh!
I'm kidding. I'm so kidding.
Oh, the truth.
He knows I'm kidding.
And the truth comes out.
Everyone knows I'm kidding.
Tonight on The Truth of Tomorrow. Anyways, Capcom.
Yes, the next comment. Comes off of Reddit, and this one comes from Streetwind, saying, so basically, SpaceX wants to go to the Mars, but in the 2020s, Blue Origin wants to presumably go to the moon in the 2020s, and ULA wants to develop a cislunar space architecture in the 2020s. This is literally the best possible result. Why choose your destination when you can have all of them at once?
We're going everywhere.
Yes.
We're going everywhere. We're going everywhere. And I think a really cool thing to add to that is that you have to remember that Blue Origin is competing right now to develop the engine for United Launch Alliance's Vulcan rocket. So if that ends up happening, there may end up being some kind of partnership with Blue Origin in cislunar, with their cislunar architecture. I'm just going to throw that bone out there.
Yeah.
That wild speculation firecracker into the gasoline pool of the unknown in spaceflight. I guess is the best way to put it.
It could be anything.
So, yeah.
And then there's the whole Bigelow Aerospace aspect to that whole Cislunar 1000 plan as well. That's going to be, partially dependent on Bigelow Aerospace if United Launch Alliance is able to move forward with that plan.
Yeah, and of course, we are literally we're on the cusp of the spaceflight equivalent of have your cake and eat it too, with all of the potential destinations that are going to be opening up, and not just because of Moon and Mars, but also because of these big rockets that are coming up. For people like me who are scientists who study things, and we've only flown past Uranus and Neptune once.
Right.
In our entire exploration of the solar system.
That means we don't know everything.
So we don't know everything. So having rockets like this means that we could chuck really big scientific probes there in a very reasonable amount of time. And that makes me just as excited about sending humans to the moon and Mars, is because now we're finally going to have this architecture to enable us to really go explore places that have never been explored before. And to me, that's just as thrilling as sending people to the moon and Mars. Maybe not for other people. I mean, I can understand that because, let's face it, humans on other places, I mean, it just doesn't get much better than that. But at the same time, you got to remember that other aspect of it too, which is that I can't handle it. I can't handle it.
As Spaceman Spiff in the chat room is offering big fracking rocket.
Yes, I will take that. Big fracking rocket.
Gotta love a
Yes.
little Battlestar Galactica. So the final comment for this week for hashtag New Origin comes off of Reddit from Brandon Mark saying, for anyone interested, here's the graphic of all those rockets, but now with New Shepard for comparison. It's somewhat unfair comparison as New Shepard's not an orbital class rocket like all the rest, but it's worth illustrating how Blue Origin's future compares with its present.
Yes, and there is that graphic that you can see right there. I'm trying the best I can to see.
You can see the New Shepard in between the Delta IV Heavy and the first two-stage New Glenn rocket.
Yes.
And you can see too how with that first one, the New Shepard is essentially going to be, they're going to make modifications, but it's essentially going to be the upper stage to the New Glenn rocket. And you can see how with that first two-stage version, how it would pretty easily fit inside of the fairing there. So
I wonder if they're going to
pretty interesting there.
I wonder if they're going to keep that fairing like metallic looking like it is, because that would be like a really cool addition to it. You know, it's like, yo, we could put some. We heard you like chrome, so we put some chrome on your rocket for you. You know, kind of deal. That'd be really awesome.
Oh, that's hilarious.
Depending on what it's made out of too, it might be cost saving to not paint it and just polish it and leave it like that.
Yeah,
so
that too. I mean, that's
save on weight is what I meant.
Yeah, exactly. Right. Just like with Shuttle, you know, with the external tank, they painted it white because they thought that would work well, but they're like, you know what, we could save 500 pounds of weight if we don't paint the darn thing. And
which is a lot.
That, I mean, every ounce counts in space flight.
It's funny,
so.
that particular image reminds me a lot of if you go to Target, if there's a Target close to you right now, and you go in the kitchen section, kind of where some of the glassware is for the kitchen stuff. Just stay with me for a second. There is a small 12-ounce water bottle that has a bunch of rockets on the outside, and including Shuttle. It's got like Atlas, and it's got Falcon and Shuttle, and it's got a bunch of them. But that's what that graphic reminds me of just all these rockets on the outside of this cute little kid's water bottle that right now you can get at a Target near you.
So now we know where you shop.
Oh man.
I shop at a lot of places. I happen to previously work at Target, and so yes, I do shop there.
Gotcha.
So there's that.
Very, very cool.
Anyway, this week, of course, is 9.30. Hashtag no more Spuds.
No more Spuds.
Spuds is a guy I don't get no love from me. And next week we have Fraser Kane. Sorry, I said Fraser Crane because of course I did. Oh my goodness, from Universe Today, which is going to be very exciting. Let's talk about some cooperation. We've had some cooperation and with Universe Today. And like I said, all ships rise to the tide, so we always like to see other new, interesting space websites coming to the forefront.
Yeah, and Fraser's also an awesome guy as well.
Really, really
He's so cool, especially with his science, his YouTube videos that he does on specific science subjects.
And he's also on Patreon, so feel free to support him as well.
Yeah, he is. So that's it for 9.30. Thank you so much for watching us today. So on behalf of Tomorrow, enjoy the episode, I suppose. Yeah. And we will see you next week. So, bye-bye, everybody.